police are rarely there to protect you. They're there to
take the information down.
take
That's
the information
yeah,
and
exactly.
call the ambulance and body bags.
Yeah.
It's a misnomer. They gotta be right next to you.
Well, out there, they're not going to be out there very big. They have too much territory to cover.
One more step and then I can continue, then I can go. I need to change meetings so it goes to our thing. One second. My channel and the June meeting. Okay. And
I think I'm going to take that cage that I took off of there, off the front, and I'm going to split that in half. And then I'm going to use that half and take off all of it but that square box. And then I'm going to attach this to the square box and using the clamps that are still out there with plastic. So I think that's all going to work out okay.
That'll help not having to read
Yeah,
geometry.
right, right. I got to looking at that and I thought there should be a use for that. So I've got it in my workshop now. And I got to looking at it and I thought that would go on the square part from just, it's an octagon, so it's got 8 sides instead of 4. Just connect the 4 sides. Away you go, you're good. And if you have to do some bracing, you can brace off the corners. No problem. It's stout enough, Some of that stuff they got by pretty cheap. They use some pretty good stuff.
The people who designed the guy who built it.
Yeah. Other areas they went overboard on.
Was that before 2000 or after 2000?
That was 2005. 2005 was when the guy brought it in and he put it together. So it was actually 2003 when I think it was 2003, 2004 when we worked out the technical sheet on it, and which the guy just tore apart anyway. Said, well, do we need to do this? I think we could do this, and maybe we could change this, and I told him, I says, I want to make sure everything gets baffled. All the optical tube has to be baffled. Well, here's some plastic we can wrap around. No, you do not understand the baffling stuff. Good God, that was awesome.
all right, we can finally get started. Only 18 minutes late.
Oh, that's good.
All right. So, I guess our schedule. I don't know, what is our next? We have next general meeting is July 28th, it looks like. And public astronomy night is July 30th. All right. I was going to ask, do any of you have any astronomy news you want to talk about? Okay.
News dealing with astronomy? I don't think so,
All right.
The universe is still out there.
as far as I know.
Then just a little intro about some summer constellations and objects, and then to the main presentation about astrophotography colors. Just some things I learned about astrophotography colors.
I learned that I don't want to waste my time doing that because I never get it right.
Sure.
Thus the response earlier.
And move stellarium over to the window I'm recording. I'm really slow today.
Are you using your laptop camera?
Yeah. And it's recording the screen at the same time. Yep.
Can you make it
Let's see. Yeah, one person, two people maybe. Okay. One second. Forgot how to go to window mode in Stellarium. Stellarium window mode shortcut. Adaptive. F11. Okay. All right. So we'll just.
Sideways.
Is it sideways? I think it's just the angle we are for the coordinates, RA and deck. Yeah. I think we're
We're on the horizon.
on the horizon. Well, don't want to do month, huh? So let's just do a couple weeks from a week or so from now.
July 4th, first, let's go.
10/22. Okay. Show button mouse. I'm gonna dim the lights a little.
Scares me when somebody like Russ walks across the floor, you see that vibration. Think, how well built is this?
Okay, so, all right.
That's what we do, cluster.
And I'm gonna turn off some of these. Let's see. Okay. So let's start off with some constellations. So Cygnus is pretty good summer constellation, and lots of good stuff in there. That's probably Sagittarius. Maybe used to be my favorite, but I kind of like Cygnus now. Has lots of good stuff.
Well, Cygnus is a lot better to shoot. than
Yeah,
Mars,
it's
right?
straight up. Yeah, or straight up later, at least, rather than at 10 o'clock, 10:30 next month or next couple weeks. But yeah, but I also Sagittarius is pretty good, and Scorpius. I think for public nights I usually just stick around and Scorpius, Sagittarius, and Cygnus. The ring nebulas and Lyra. But also, I don't know, M13, you have Hercules, M13 and Hercules, and, I don't know. Dave, do you have a favorite? Gary?
I kind of like to shoot, let's see, the Crescent.
Oh, yeah. That was, last time I tried, that was really hard.
It's a difficult one to get really good depth on, I noticed. It fits the field nice, though.
I tried looking at it in a telescope and I can't really see anything
I
either.
never could see it visually.
Yeah.
We used to work on trying to see the horse head, and the horse head was challenging a lot of times. I saw it in 17 and a half inch going but it takes a good night. You can't, and this thing is so widespread, it's really difficult to see that there's any deviation between one spot and the next.
The first object I ever found in a telescope, besides stars, I guess, the first non-star thing was the Ring Nebula. It was kind of easy because you could just find these stars and it's like in between the two. So I thought maybe this year I should try to take an image of it since it was the first thing I saw visually. I might as well. Can take a picture of it. Maybe try to take a good one. I know you took a good one a year or two ago. And we just got, I think it was when testing the new mirror coating, I think.
Oh, okay.
Yeah. But in general, there's lots of stuff, and
That's nice and bright. It's small, but it's nice and bright, so you can play with it pretty quick. I mean, you can take 30-second shots and come out with some decent, even color.
yeah, if it's an okay night, you could see it pretty good just in a finder. That's probably also why I was able to find it. I think I had a 7X finder or something,
Yeah.
and it showed up.
The Horsehead Nebula's in Orion, isn't it?
Yeah.
I think it's just mentioned it because that one's also really hard to see. But
Well, that's what we used to use for a visual base. If in the winter, if we were out trying to figure out if we got a decent night or not, we always went down the Horsehead. If we could see the Horsehead, then we know it was a good night. If we couldn't see the Horsehead, then it was kind of an average for night. Even if it's cloudy or clear, it's still.
Some weird names up there. Tweedledum Cluster. Flying Unicorn Cluster.
Yeah, people like to put in their own.
yeah,
And I always have trouble with that.
Phantom Streak Nebula.
Blue Racquetball Nebula?
Oh, really?
Yeah. So
Oh, I
made of
see.
Tweedledum.
It's up above Tweedledum.
I don't, there's been some traditional names that have been around for a long, long time, like the wild duck cluster, that's been around for a long, long time. But some of these new ones that people are coming up with, it's like, and they're trying to get it established to call it that because it was their idea. I'm
Yeah.
sorry, I don't
They have all
care.
these other names up there. Planet Krypton Nebula.
yeah. I don't know. Like
Turquoise.
the Wizard Nebula, people are trying to call like the Harry Potter Nebula or something. And I see Harry Potter and the Golden Snitch.
I'll just go by the NGC, thank you.
Yeah.
I grew up with the NGC, so that's what I use.
Also, I don't know. I'll just go through maybe three of them. Also, three of my favorite objects, maybe like Lagoon and Triffid are pretty good ones in the summer, I think. So here's Lagoon and Triffid. Depending on your field of view, you can see both of them in the same field. And then Swan, I like too. I usually ask people if they think they could see it as an upside down swan, and they're like, I don't know what you're talking about. So I could see it. You got the beak here, and here's like the water line. I don't know. So anyway, I always
It's
ask,
just
like,
kind of
no,
swimming upside down.
like, no, I don't see. It doesn't look like a swan to me.
Well, there's the rabbit in the moon, the woman in the moon, the man in the moon.
Yeah.
I think there's lots of those too.
And I
Drinking
also-
and guns don't go together, and drinking and astronomy don't go together.
I like the veil too, but a lot of people can't see it, even when I show it to them. It's really hard.
It is. That's a tough one too. Yeah.
You photograph that a lot. At least it seems you
I
do.
tried. I photographed this part and this part.
The amazing part to me is that it has those blue reflection nebulas in there,
Mm.
along with the emission lines, and they tie together. I mean, they intertwine. It's pretty wild.
That's from a Nova, right?
Yeah.
Mhm. I was gonna try to this summer take another picture of it with a wide field camera, like the whole thing.
Yeah.
maybe like 135 millimeter or 200 millimeter, something like that.
The trouble is getting depth on those because you tend to wipe out the, you know, you tend to wipe it out, and the longer you go, it tends to not gain anymore.
Oh, yeah.
It's kind of like the old reciprocity failure from film. And it's just a matter of our skies on this dark.
Mhm.
Yes.
Yeah. And yeah, and M13 is good in Hercules, mentioned before. Okay.
So, okay, so and what are the bloated stars in there? Because that doesn't show up in a picture, does it?
No, I think it's because yeah, they're
Because they're
stellarium
just-
stars, and you could
Yeah,
pick how
okay.
bright, like
Yeah,
their
alright.
star, how big the stars are in their star catalog.
Yeah, right.
Yeah. So like you could say, all right, show anything above this magnitude and make it be this big, these
Right.
stars.
Right.
So, right, if I zoom in, I think those will just go away.
Yeah, well, they do blend in then more.
They blend in more. Or you could also shrink stars and then they would go away, or maybe you can even turn them off. Yeah. When stellarium first came out, it was trying to simulate how it was visually, so all objects were black and white.
Mm-hmm.
And I think they didn't have as much care about their star catalog or every star having a label. It's changed quite a bit since when it first came out.
Yeah.
When it first came out, when I found, or around, or when it was doing the visual thing was around when I first found it, and that's what made me get into astronomy, actually.
That's brighter than the Ring Nebula. The Ring Nebula was 8 or 9. That was
Yeah,
like
it's,
5 or
but
6.
keep in mind, the Ring Nebula is a lot smaller, so you have that light concentrated down into a smaller area.
So this has surface, well, it doesn't really, I mean, I guess this has surface brightness, but they're also just a bunch of stars too.
Yeah,
This
they're
says
individual
11.
stars, right.
Ring Nebula, surface brightness 10.94. So, but M13 is very bright too. And Alberio is
Yeah.
So that
good.
the Ring Nebula is also from a star explosion, right?
Right.
Yep.
So
Right.
I remember looking up recently, why do they call it a planetary nebula?
Uh-huh.
And I forgot why.
Oh, I can tell you, because they're small and round.
That's it.
So they look kind of like a planet when you first come across them, because they do have some size versus a star, and they look small and round.
It's deceiving
Yeah,
name.
it is.
Yeah.
It is. That they should be called supernova explosion remnants or something.
Or something, because it makes you want to think, oh, nebulas are from an explosion, so a planet exploded.
So SN REMs, that's what they should call them.
Yeah.
Supernova remnants.
Well, they're not always supernova. I think this one's not. So like the Veil's a supernova, but this is just a dying star where the outside layers of the
Isn't that
star are being
nova
pushed
at one
off.
time?
It's not I don't think it's an explosion. It's just a star that is end of its life.
Puffed
It
out.
shedded
out.
out,
puffed
it
out,
shedded
shed-
its
yeah.
outer surface.
But like I think the Veil's a supernova, but you know that is like all over the place. That these planetaries are just without the explosion.
Isn't there a star in the center?
Yes.
And also M27.
Yes.
That is also a one that has blown out, or was that caused by an explosion?
I think also blown out. Just
Yeah.
not explosion. Yeah. But crab is an explosion. M1.
Yes.
Right. Which is not up in the center for people online. But I don't think this is considered. Yeah, this is not. Yes, supernova remnant, whereas ring nebula is planetary nebula, which so the planetary nebula are just from the stars blowing out, and then like M1 is a supernova remnant.
Okay. I thought the difference was maybe from supernova to just nova.
Oh.
Is the star in the center of the ring, is that the star that lost
The
its...
progenitor
Mhm.
star, yeah.
So it's still
It's not-
illuminating.
it may not be the brightest one there. It may be a dimmer one that's in the center.
Oh.
Because does that blow up further?
Oh, yeah.
Right, but you're right, it's, yeah,
Probably like this one, maybe.
I guess that is it. It certainly looks centered.
So,
Sometimes you get fooled, you think that there's a star in there that looks close to the center, but it's actually a fainter one nearby, and it's actually.
I read where the Webb telescope first images are supposed to be published in a week or two.
oh. Nice.
So that'd be interesting.
Yes.
So, I think the first one they took was the moon, and they took that area where the flag is.
I thought when the article I was reading made me think that they were going to go for the Hubble Deep Field and try to
Try to beat the Hubble Deep Field.
beat that.
Well,
So-
good luck. It was like 30 hours of stuff or more. I don't remember what the total was, but it was a long term.
So supernova are from stars that are greater than 8 solar masses, and planetary nebula are in stars that are between 0.8 solar masses and 8 solar masses. So not big enough for the.
So our star is like not going to go nova.
Right.
It's going to be. It's just going to
Right.
blow out that.
Mhm.
You know that.
We'll just be a speck in the rain.
Will just be a French fry out on
Or
the edge.
Or, you know, before then, I think the star will actually go to red giant or
Yeah, red
so-
supergiant.
red-
Well, basically red.
Yeah, red
star.
giant. So I don't know that we would be at a speck.
No, we wouldn't even be in existence at that
We'd
point.
be dust.
Well, there'll be some dust particles
Yes.
out there.
Yes.
Yeah,
Okay.
Stage 2.
we'll be the French fry that's sitting out here.
Burnt fresh.
Alright. Well, some objects to look forward to this summer, maybe. Alright, so the main topic I was going to do is on color. So start first slide, okay. So, I guess first off, a warning. I don't know everything there is to know about it.
But we assume that.
Nope.
In our book, you do.
No. But I've learned more, including this week. So
Mhm.
I tried to have some more, especially toward the end of this presentation, some more actual like examples of what I mean. Anyway, I'll talk about that, but I failed completely. But I'll show you what I was attempting. I'll explain what I was attempting to do. But anyway, so color and astrophotography. First, we might start with just about color and our eyes. So
Yes.
both of these represent sort of what our eyes pick up. So this is like our sensitivity to color. So we really, sensitive more to the green or
And that
teal
was developed
area?
because our sun is that same color.
Yeah, it doesn't seem like our sun's that color, but yeah. And then here is actually showing the cones. There's 3 cones and their relative sensitivities. I think SML, they all blend into our brain to show color for us. So it's not like
And color looks different for most people, by the way. There's not very good definition of color for somebody who sees a blue color. They might associate that to be a little greener. I mean, there's no standard candle here. I mean, you just go by the wavelength and that gives you exact color, but people's interpretation of that color is a little askew.
yeah. So it's like, is my green your green?
Yeah,
Probably
exactly.
Right.
Cindy and I have a lot of different variation in that. What I call something blue, she calls it green.
Yeah.
Or, yeah.
My color blindness is like a dark green and a brown, I can't see the difference, or a dark orange and a red, I can't see the difference.
I had a friend of mine who had his pilot license and he had a restriction he couldn't fly at night because he
Yeah,
couldn't.
that's the reason I
because of
didn't become
colorblind.
a pilot, was because of those, the numbers and the little dot things.
Yeah.
the
Yeah.
instruments.
I can't.
Yeah.
I can't see it. There's only a few I can figure
All right, so now how do you go from, all right, so now we know the eye picks up color, but how do we see color in images and monitors? And basically, a lot of the monitors work because they have, they might have, they have a pixel, which each pixel has 3 colors in it, and then it's far enough away that those energies blend together and hit your light and and then it makes your brain think you're seeing that color. So a lot of image formats, especially, or when the data gets sent to a monitor or this projection screen or a TV, it's very common that there's just 3 channels that it's sending for every frame or for a picture. So, for example, this image on the right is the color image, but you could split it up into 3 different channels: red, green, and blue. And it's telling those red, green, and blue how much intensity of each of the red, green, and blue to be in for you to see it. So there's not actually, like on your TV, usually like a brown pixel. There's no brown pixel. It's just a different ratio and brightness of red, green, and blue.
So that's why at Farpoint, the camera that looks at the tombow from the side, the black shroud always shows white, and that's because it's using red.
Well, it's infrared.
It's infrared.
So it's even one outside of these.
Yeah. It'd be clear over to this side.
Yeah, I was talking to Gary about that because it was like, the camera probably picks up the infrared, and to the camera that the cover is white.
Yeah.
So they actually make material that is more, it's even dark in infrared. But, they're like special materials that you make. I think probably that material is made out of wool, and it probably reflects infrared because sheep want to block the infrared or something. I don't know.
Yeah, I know that you can buy paint too that's infrared. I think most of the high temperature paint, if you get a black high temperature paint, that's generally also sorbs infrared, so it doesn't reflect infrared back.
So is it shooting a light that's infrared, or it only picks up infrared on the sensor?
So in that case for the camera that's at Farpoint, it's pretty dark. So and that camera is sensitive in infrared, and in general there's infrared, all over the place, really. Sort of like I don't know, at least as much as light there was in that spot. So it just infrared hits that material and bounces back.
So it doesn't have an infrared light on the camera, like the one at the walkway has an infrared light. Because you can pick that.
Right.
That thing blasts light, which is really nice. Blast light out there.
The interesting part is that the red cylinder there its actual color is everything but red.
Okay.
It's reflecting the red back to you.
Yes.
But it's absorbing all the rest of it.
Mm-hmm. Yep.
So
that's amazing.
It's weird the way
most people don't think of those things, but color is not really the color.
No, it's a wavelength. It's
Yeah.
just a wavelength. It's different. Shorter or faster.
In the reality outside us, that's not red, right?
No, I mean the pigment in that cylinder has just reflects red back and absorbs all the rest of the colors.
But outside the reality outside our visual, that's not a red cylinder.
No, it's everything but.
Yeah.
Exactly.
Yeah, that's a mind blower.
Yeah, it's a negative red.
Right, like we see the inverse.
Yeah, right.
Kind of. Yeah. All right. Anyway, okay. So now, talking about cameras. A lot of times we get our images from cameras, and so there's one-shot cameras like in your phone or a SLR, where you take one picture and you get a color you get a color picture. So it's like, how does that actually happen? And it happens because the cameras actually have a thing called a Bayer matrix. So they actually they alternate on the pixels what kind of color filter that they let, that is in front of the pixel that lets the light through. So a common pattern is RGGB. So it goes, you know, you have a red pass filter and a green pass filter. Then the next row is you have another green pass filter and then a blue pass filter. So
you actually end up with more green than anything else.
right, just like in this image over, you know, this image here showing the pixels. Yeah, you can see there's a lot more green.
The ratio would be 3 to 3 to 4.
And, yeah, and they do that. Like, yeah, notice, you know, what's kind of special about green. You know, if you go back to our eye, like we're saying, we're more sensitive in the green area. So we actually, our eyes could pick up more detail if you have more detail in the green area in the image. So that's one of the reasons why they do that.
See, I don't see green. Maybe that top
Oh,
one
really?
is green to me. All the others seem red.
Oh,
Is that
okay.
top one green?
Yeah,
Not but to the right of where your cursor is.
that's red.
That's red.
Which ones are green?
This one's green.
That one's green.
That seems yellow to me. So I can't see the difference. Which ones are
It's
green?
a light
This-
green. I
this
mean,
one's
it's a
green.
green
Are all
yellow.
of the? Is that green?
This is green.
See, that
This
looks
is green.
yellow to me.
Well, the yellow ones are green. Probably. Do you
Oh.
see four?
I'm
Or
okay.
do you see three colors? Right.
Yes, I see three
Okay,
colors.
so
So
the
the
yellow
yellow
ones
is
are
green.
Yeah.
Okay, because I was thinking like, man, I am way worse than I thought.
I mean, it is a very bright green on here. It's not a dark green.
Okay.
Okay. Yeah.
It's a
Okay.
lighter green. More like I would call, let's see, what color would that be? Can't come up with
Neon
it right
green.
now.
I don't know.
Yeah,
close to neon green.
it's a
Okay.
brighter
Yeah.
green, yes.
Right.
So yeah, so this right here is a diagram of the eye too. These are the cones of the eye. And yeah, you know, here's the actual colors. But notice like this green, you have all the cones actually pick up a little bit of green. So
Unless your rods are way low and then it just picks up anything. Everything looks different.
so if you have a mono camera though, you can't just take one picture and then you have the color information. You have to take several pictures, each with a different pass filter in front, so that you get those three channels that you can put together. You get a bit more color resolution this way. You know, here, you know, behind the scenes, when you actually look at the image, you have some algorithms that interpret the different colors for the colors that you don't have to keep the resolution. So, you know, it will take, you know, this pixel right here is a red pixel, but the camera will take like the surrounding green pixels and assign it a green value even though it's not a green filter. So
I thought one time when you and I were talking about this that a pixel can be divided up into sections. Am I misunderstanding?
like you could
You had the
yeah.
pixel divided up much like that.
A single
A
pixel?
single pixel.
I thought a single pixel had to be one color.
Okay.
Well, I mean, the pixels on like a TV usually are usually when they advertise the resolution, the pixels on a TV have three colors in one. But for these cameras, yeah, they just have one color per pixel. But then they do some math to try to get the color of the pixel where that filter's not.
So if you've got photons hitting the red pixel and the greens are all around it,
Yeah.
and if the red doesn't get enough photons and the greens get more photons, then it kind of bleeds over the red.
Mm-hmm. Sure.
I mean, it's what it would appear to be.
Also that there's a bunch of different kinds of algorithms, but it also like tries to fill in the blanks for the colors that it's not there too. Yeah. So you get higher color resolution when you use the mono camera with a filter in front.
You get richer colors generally that way.
Richer colors using
Using the
red,
mono camera?
using red, blue, green compared to the
using
element ones?
Yeah. I
So-
think you do anyway.
So I have this later on, but I have the frequency distributions of mono filters and typical Bayer filter cameras, and you could tell that there's a difference, and I was going to talk about that some more. The actual when you use a mono camera, you can use any type of filter that you want, and you get very specialized red, green, blue filters that are.
Use hydrogen alpha for one, and that will pick up that will really intensify the hydrogen gas clouds and eliminate everything else that's even close by.
Yeah, and these could be really high quality. Like they let a very defined group of the frequency of like reds in compared to maybe like the Bayer filters where you can't get as specialized filters. But that includes these narrowband filters, which I was also going to talk, but also the broadband red filters. You can have it where they transmit everything within these frequencies, like almost 100%. Rather, probably what's in your camera and DSLR on those Bayer filters, I have graphs I'll show you, but they're not as well behaved, I guess.
Yeah.
So yeah, color with mono cameras,
They kind of stretch over a little bit over each other.
Yeah. Oh, yeah. My next slide. So yeah, you just so right, we have all these filters and stuff, but does it really mix? Does it actually end up being like how we see it in real life? And the answer is like it's actually very complicated to take an image and make it seem like it's like how a person's eye would see. So I have some of these. Where's my mouse? So this graph here is sort of like a typical response it's actually the Canon T3i response. So but you can see these black outline ones where they're blocks. This is a Astronomics RGB filter, and you can see that they're much more defined. It pretty much gets all the red almost at 100% response compared to the T3i red, where it's sort of like a slope here and then it goes back down here, right? And
But
same with the blues.
So the T3i is a lot more red sensitive than what I mean, it looks like it's a lot more red sensitive.
If that graph is correct.
But I thought they were kind of blue-green.
Yeah, when I take images, it seems like the blues always really show up.
Yeah.
But
it's
this
broader.
graph could be wrong. It is broader, yeah. I mean, you even got the blue going all the way across to the red.
Yeah.
Yeah. So like the blue filter in the DSLR is picking up a lot of red relatively compared to just straight blue.
Mm-hmm.
So it's not. Whereas if you have a RGB, you could get a blue filter that behaves very well.
Which
It's
is probably
just
another reason
cut off.
why the colors kind of fade into each other, and you don't get a distinct break from when you do one of those colors. When you take a color film instead, there's a color chip instead of a black and white chip.
Yeah.
Black and white, you can divide them out really sharply, and with the color chip, it spreads them out pretty.
And then, but you also have the camera itself is sensitive to different wavelengths.
Yeah.
So you have that in combination with whatever filters are
right.
in it.
Yeah.
So this is the ZW ASI 1600 mm response. So
It actually does pretty good.
yeah, but it's not like 100% all the way across this entire
Oh, no.
spectrum that picks up, right? So if you take this and overlay whatever filters you have onto it, it's not going to be also even. So you got a lot going on here if you want to get try to emulate the response of the eye, but people do it like the DSLR camera. They have that Bayer matrix. They have these filters that are like really wide, pretty wide spectrum really, And what they do is they do a lot of processing on it to try to get it to look more like your eye would see it. And one of the things that they do is a color correction matrix, where it takes data from all the channels and mixes it in for each channel. So it takes some values from the blue and the green and the red and assigns that blue pixel, and does the same for all of them at different ratios. So when you take a picture with your camera, they have that calibrated with like color references and everything. And that's actually it's pretty complicated to do. So some astrophotography software does not apply that color correction matrix. All you could do is a type of white balance, and the white balance usually is not enough, because the white balance just tries to match the background and range values so that your whites and grays are kind of gray, but it won't really bring out the reds like you expected. So these are two images that I made. Do note I'm still not an expert on colors, but I do like this image on the left. I think it's really cool, but it doesn't really, I can't really see much of the reds. I kind of lost all the reds. A lot of the colors are just really weird. I mean, it is a lot easier for me to see like the background dust.
Needs more green.
Yeah. But this one, yeah. But this one on the right, I actually put it through some software that applies the color correction matrix, and then I did the same process, right?
So is that from a color camera, or did you use filters?
This is from a one-shot color camera with that Bayes matrix. So this is where it's especially important that you have a color correction matrix if you want to try to get true color, or whatever that can be.
Yeah, and true color is so difficult to describe. I mean, the thing of it is, I mean, even the colors you see here are extremely concentrated compared to what, I mean, your eye can't even visualize this faint of a color. So the problem is when you start increasing the intensity of the colors in order to bring the colors out, you're actually overexposing those colors for what they are naturally. So the people that have these reds, blues, and greens strong in Andromeda Nebula, I think tone it down. Please tone it down.
Yeah, it
because
seems like
because
a lot
they're
of
not
what
they're not
appears to
that
be
way.
nice astrophotography
Yeah,
is just
bloated with-
manipulated to as vivid colors as I could
Right.
possibly get,
Yeah, and it's
not
like
so much.
That's not the point, guys.
Yeah.
That's not the point. But everybody's got their personal opinion.
So I mean, I was going to show you real quick with and without color correction matrix. So some astrophotography software will apply your color correction matrix if you take a raw DSLR photo, and some will not. So
A lot of times you can set whatever you worked for this particular region of the sky, and you shoot it again some other part of the sky, and you can try to apply that same correction to both skies, but they just don't always match up very well. You still have to make some minor corrections because condition of the night, how much moisture you've got in the air. I mean, there's a lot of factors involved here.
So this is a single shot of M8 or Lagoon Intrepid. This is with the color correction matrix applied. And here's the same thing without the color correction applied. So, but this, you can also, if you do white balance, it does show better. So I could do color calibration, photometric color calibration, and this will actually do white balance using photometric data.
Thinking.
So is your 1600, is it a color or a monochrome?
mono. But I took this with Canon T3i.
Oh.
So, yeah. Okay, so this is with white balance applied. So it's actually, you know, it improved quite a bit. You don't have everything's not all orange.
Yeah.
Yeah. But you can also apply white balance still to this one, photometric white balance. And I don't know, didn't find stars on this one. Let's see. Okay. Well, sometimes I can't get photometric to apply. You're supposed to do it, I think. But you can also do it this way to.
And photometric just trying to work on just narrow band colors and trying to apply put together narrow band colors versus broader band colors. Is that what that is?
It's actually just uses stars as a white balance reference. That's what this one does, at least. So they look, you know, they look kind of close. You can tell one has a little bit more pop in the red. Also keep in mind this is in a projector. The projector doesn't have very good color.
Yeah.
But the color correction, the colors kind of pop out a little bit better, I think. So if you're using an astrophotography editing software with an SLR, you might want to look to see if there's actually a way to apply that color correction matrix, or see if you use some software that does. Like I think AstroPixel processor uses the color correction matrix. Serial does not. So if you're just using Serial directly on your SLR RAW files, you're not applying the color correction matrix. So you have to do it ahead of time or use something else to do it. If you care about that.
It can get pretty complicated pretty quick.
Yes. And oh yeah, so I was gonna show this one too. So I took my mono camera, and I have RGB filters for it. So I was like, okay. So I was like, I was actually gonna try to generate a color correction matrix, and based off of a color reference. So I created this.
Is it the wrong tab? There's one that says Russ up there.
Let me close some of these. Sorry, I might be getting confused. It could be that I didn't end up copying some of these files. Let's see. Okay, I guess I didn't end up copying I took a red, green, and blue picture, and then I combined them, and you can see how bad the colors are actually, even though these are broadband, mono, astrophotography, although they are cheap, but they are mono filters. So a color correction matrix is actually kind of really needed there still, because like the pinks don't show up very well at all. And I also forgot my I forgot my color reference. But slideshow. I don't know why. Okay, color. I'm on here. Okay. Yeah, so we were talking about narrowband palette. Oh yeah, so narrowband filters. they're even more different. Right? So they're small segments of like in the blue or the red. You can see it's hard to see, but the green is considered like all across here. But you have this O3 that's just kind of actually in the middle of green and blue, really. And you have these two narrowband filters that are both red. So some people, they will put those and they'll assign each a channel, and then you see those. That's sort of like what the Hubble kind of does sometimes. And
The Hubble palette.
yeah, it totally doesn't look real, I guess, but it shows a lot of information. But
It distinguishes the silicon with, and the oxygen. Those two specifically, and then throw in the hydrogen. So now you've got three very distinct colors and narrow distinct colors for, an object. And they are significant because that way you get to pick out the silicon and you get to pick out the oxygen and you get to pick out the hydrogen.
How come there's two hydrogens?
Oh, hydrogen alpha, hydrogen beta, that's just where the fingerprints line out, the Fraunhofer lines of the spectrum. So hydrogen has multiple points along the spectrum. It's got one in the red, it's got one in the blue, and then it's got a few smaller ones in the green, and I think and then bluer ones go down.
it's
too.
when the electron's in the outer
Excited
area,
state.
and then it comes back when it falls back down. There's different levels. So you could go like 3 to 2, 2 to 1, 2, 3 to 1, and all those shoot a different kind of light out. So hydrogen alpha is one of those excited states back down, and hydrogen beta is another one. And so one atom can output
Has a lot of
multiple
different
kinds of
colors.
lights. Yeah. So hydrogen alpha is just one of those electrons from one state to another, and hydrogen beta is from another electron state to
But
another.
they're very specific lines, though.
Yeah.
Very specific colors.
I had this demo.
Spectrum actually is just amazing to me. I heard rumored that we were gonna get into it at one point.
Oh yeah. So here's like a Cloudy Nights article where they take some
Yeah.
images, right? And yeah, so bottom left is SHO. Bottom left, this one.
Yeah,
So
that's SHO.
like,
That's the Hubble palette mainly. I mean,
Yeah.
that's-
and then bottom right's a modified one. I don't know how they
So
modified it.
if you stop right there, so bottom left, SHO palette, sodium, what's G?
That's visual. That's just visual.
Oh, that's red, green,
Well,
blue.
they took hydrogen alpha and made it the green channel.
Yeah. Yeah. Okay, I see.
R they assigned R to be
Silicon and
S2.
hydrogen alpha, those two both combined.
So that's a 3-filter image.
yeah. But they're the narrowband ones.
Yes.
So
Is it silicon or sodium?
Silicon, it's a silicon. The Si3 is silicon.
I thought it was sulfur.
Is it?
Let's see,
Maybe
narrowband
you're right. Maybe it is sulfur.
narrowband filter.
I thought it was silicon.
So there's multiple
It's sulfur.
Sulfur. Okay.
sulfur, there's like a S2, S3. It says SII, is that represent
Right.
sulfur 2?
Yeah.
That's it.
The-
That's it as at the double valence. We're not looking for here. It's a different energy level. It's the energy level of sulfur that has two. There's a sulfur 1, a sulfur 2, and a sulfur 3, and probably down the line.
Just like for oxygen, it looks
Yeah.
like.
Yeah.
Right.
So all these, the principal lines that are very intense, hydrogen alpha is a lot more intense than hydrogen beta.
So it appears, if I'm remembering right, that a oxygen 1 is cheaper and an oxygen 3 filter is expensive.
I don't even know if
Or
oxygen
it's
1
more
is
of a
even
brand.
sold. very much.
It's what?
I don't know that there's an oxygen 1 filter that people
I don't
buy.
think so, because the oxygen 3 is the one that's most prevalent in stellar areas.
Yeah, it's more about
Nebulous.
the light or the electrons light frequency that's out rather than
There's a 1, 2, and 3.
there's lots.
There's
No.
tons,
Yeah.
yeah. The predominant ones though are marked 1, 2, and 3. I mean, like hydrogen alpha is alpha because it's the most predominant one of the many lines that make up hydrogen, okay? So there's that big red line that's hydrogen alpha, and that's so intense that everything else is, lower than that. The hydrogen beta is not as high a frequency, or not as high a frequency, it's not true.
So in that
It's-
Cloudy Night article, it looks like
Intense.
all that guy is doing is taking the, I don't know what else to call them, chemical filters and assigning
narrowband.
them to different red, green, blue channels.
Yeah.
That's what a lot of people
Yes.
do, yes.
Yes, right.
And that means that, like, if my oxygen is this band, if I put it in the green, then I'm only seeing that much of that. Is that right? It's like a the filter on top of a filter concept.
What they're doing here is they're taking a hydrogen alpha filter, which is a hydrogen, and they call it a orange color. They just assign a color to it, okay? So they're just telling it, this is gonna be green on this particular image. and
I would adjust the colors.
They adjust the colors to match.
Really hydrogen alpha is red, but
Yeah.
they're making it green in these SHO
Right.
palettes.
Right.
Because it looks nicer.
Because it differentiates.
Because it would all be red, I guess, You'd have mostly red image.
Yes, especially sulfur 2 and hydrogen alpha. You put those two together, they're both red. One's a little redder than the other one, but they're both red. If you want to differentiate between those two, say you're looking for a sulfur area along with a hydrogen area over here. In order to differentiate those enough, you make one of them blue, the other one green, or the other one red, and now you've got a blue and a red distinct difference between those two. But now you can tell this is a sulfur region over here where this blue is and this hydrogen is over here. So you can separate out at greater length. Instead of having both colors look similar, then they blend together too easy. This way it gives you a way to separate those and make them more distinct.
And assigning those to red, green, and blue is something you're not doing in the filter wheel, you're doing.
No, right. You're doing
on the
after in
computer.
processing, right.
You're doing in the processing of it,
Right.
okay.
And all that is to try to get more distinction between the different chemicals that are out that are being.
So the one that's top left and it says natural,
So there's some people that try to use narrowband filters to come up with a more natural way to look at it. So they actually mix. It's sort of a mix, sort of like the Bayer. You know how the Bayer filter was, all those camera Bayer filters are all over the place, and you sort of have to mix the red information with the green information and the blue information to try to get it more look like, I don't know, to make the tree look more like a natural tree, like how the eye sees it. Well, they try to use narrowband filters and make a synthetic natural. I think it's probably impossible because of how narrowband they are, but
Yeah,
there's attempts to do it. So
Right.
Your O3, it's actually a teal color. So there's things, some people,
Yeah.
they would just assign that the teal color, right, at various intensities, and then they would, if they have sulfur and they have hydrogen alpha, they have both of those be reds, but but some people even try to go more synthetic and really match them up through all the colors. So you see that their natural one, they take they multiply the sulfur by 75%, and they add 25% hydrogen alpha.
Because hydrogen alpha is generally the one that's the predominant. It's the one that really comes in strong.
So this guy, don't take his natural palette as truth or whatever. You'll find tons of forums with people with different formulas for these narrowband filters to try to get a more realistic look with using their narrowband filters. I mean, there's an effort to do this, especially because a lot of people live in the city and they can only really use narrowband filters in the city. to really get any data. So they,
Right.
they wish they could just take some, real red, green, blue filters and do a proper mixing or whatever. But all they could really do is the narrowband ones, and then try to make a synthetic, natural one.
You can use photometric filters, which gives you a little bit of true colors, but is not as widespread. So it doesn't, it tries to block out some of the unnatural, artificial.
So your
light.
photometric filters are just red, green, blue?
Yes, yeah. They take a bandwidth that usually is pretty strong, goes up and back down, and has this much. It has a little bit wider than the narrow band. The really narrow band filters are only going after one item, and it's the strongest wavelength of that item.
So there's two classes, photometric and narrowband.
Yes.
And broadband.
Yes,
And broadband, regular RGB.
Regular RGB.
Where
Regular
it's
RGB
wider.
is wider, and photometrics are a little bit narrower,
Here's some
and
photometric ones.
the narrow band are very narrow. They only cover one wavelength, basically.
The more narrow, the more expensive they are too.
Yes,
So you can get,
3 nanometers, for example, is
Yeah.
pretty narrow.
or even if you're going for hydrogen alpha of the sun, it's super narrow. It's, I
Yes,
don't know.
point four or
Yeah.
something. I mean, it's really small.
Which one of those hydrogen filters makes the sun image orangish, yellowish compared to the white?
Those are the film filters. I don't know exactly what they're blocking,
Okay.
but that's not.
There's
Maybe
some like the Mylar filters that you see. Some of those are tinted with orange in order to make them come out orange. They're not.
Some diagonals are specially made for the sun because it has a built-in filter. Some,
Like a Herschel wedge almost.
yeah, some have, the mylar or glass coating,
mhm.
but I know that
Dielectric coatings
they
or
sell
whatever
them, that this is the whitish image and this is the
Yeah.
yellow-orange image. So I like the yellow-orange image better.
The stuff that's been happening on the sun lately is pretty dramatic.
Yeah, there's supposed to be a big
There's a
explosion
lot of
headed
stuff
our
heading-
way.
Yeah, there's a lot of stuff going on out there now. It really, when it went from the quiet sun and it jumped pretty hard.
When it was supposed to do it, happened right when it was supposed to do it.
Right at the corner,
Yeah.
right at the curve.
So that the sun has cycles which affect everything.
They've got it pretty well locked up. I mean, it does vary in intensity each time.
Can you scroll down and show the all 4 images on that?
Yeah.
It's all using the same filters,
Just in different ways.
just in
Yeah.
different ways, and just applying intensity levels to each one, and different colors at different intensity levels.
Yeah,
For me, it seems like the bottom ones are better, like maybe the bottom left for my eyes.
Well,
okay,
and-
those are the Hubble palettes.
Yeah,
Those
yeah.
are the what, Hubble palette?
Hubble palette, yeah.
I think the Hubble's like a slightly modified SHO palette. I think
Mhm.
both of these bottom palettes are SHOs. So
Yeah.
the actual red color is in the green.
Sulfur, hydrogen, and, yeah.
So maybe that helps you, right? If you are
Mhm.
right, if you are red colorblind.
See, in high school, when you stick that little metal rod into a chemical and burn it on the
Oh yeah.
Bunsen burner,
You couldn't see the colors.
that's really what we're doing here,
Oh.
isn't it?
Yeah.
Yeah.
Well,
So that's
kind
the
of.
connection of
You're
chemicals
right.
have certain kinds of light.
At certain temperatures where
Right.
where their energy levels are higher.
Yeah.
Yes,
Yeah,
exactly.
to me, there was no
Yeah.
connection. All I was is just sticking stuff in and burning it
And you
and writing
didn't
down what
understand
color
why.
I saw. And since I was a little colorblind,
Yeah.
Didn't do very good on that quiz. Nobody even connected that.
No, probably
That
not
I'm
back then. It was
telling you what I see, but
Yeah.
you're marking it wrong.
Yeah, that's right. Exactly. Yeah, I understand
Yeah.
that.
It's
Actually, they can tint metal to certain colors by their temperature. They get a certain temperature and then they quench it real fast in a water oil, and it stays that kind of purple or green or whatever color.
yeah. When I was a kid, we used to have arguments about what color Christmas lights were. Until
My
I
wife and
got,
still
until I
argue
got
about
in
color.
front of those little dots with the numbers inside.
Yeah.
Nobody
Yeah.
knew.
Yeah, that's
And
right.
they held me back in second grade because I couldn't do the stoplight colors. Now I can
Oh,
tell
man.
the stoplight colors, so I don't know what was going on with that. But that was one of the things that was a big deal, is I couldn't do the colors. Now I can see those colors obviously, so I don't know what was going on. But
Well,
I got held back in second grade because of the stoplight crap.
Einstein and I were held back in the 4th grade
Yeah,
For math.
it helped me with sports.
for math.
You know, being held back in second grade was
Oh,
nice.
yes.
Good move for sports. Yeah, so anyway, sorry.
1 year bigger, yeah.
So here's the alpha stuff.
Oh yeah, so it looks like hydrogen alpha is from 3 to 2, and hydrogen beta is from 4 to 2. I don't know how they come up with the names O3, hydrogen alpha, like why isn't it H1? I don't know, but I'm not sure. It's a chemistry thing, I think, how they come up with the names. There must be some standard, but I'm not that familiar with it. But hydrogen alpha is from, 3 to 2.
Well, we have a solar eclipse coming up, and it's, my second one, so I'd like to be better planned
Mm-hmm.
and try to do some imaging this time.
Oh, okay.
So
Seems risky.
this topic's coming up.
I would like to see a total solar eclipse.
Yeah,
You have?
I've never seen one.
How come you didn't see this last one?
clouds.
Clouds,
Were
rain.
you guys in the
It
same
was
group?
raining.
Oh, did you go off someplace to a different location?
Oh, Hiawatha was where I was.
You were in Hiawatha.
Or Horton. We were at Horton, yeah.
Told you guys to follow me.
I know, but I was stuck. I was stuck.
Let's stay away from Cromer. He talks too much. I'm not going to be stuck in a van with Cromer and some
No,
high school kids.
I think I was president in charge of the group, and it's hard to get a group to move.
Mm-hmm.
Well,
Yeah,
and
especially when lawn chairs are out and everything.
And I was kind of committed to where I was, so.
Yeah, and I was mobile.
Yeah. So those kids were lucky.
Yeah, I don't think they know how lucky they were.
Yeah, there wasn't a lot of people in Kansas saw those actually. Anywhere.
But the good thing is I wouldn't have known that spot in Bern if I hadn't have gotten married, because my first wife's in-laws are from Bern, so I spent a lot of time in Bern.
Well, see, that was a good reason for
So,
being married.
God connects things pretty quick. You just gotta see the connections.
Look on the bright side.
Yeah.
Yeah. Yeah, I understand that.
Oh yeah. We could talk more about colors too, but I guess remember, like, all that really matters if you like your image.
Mhm.
So it's like
The thing that kind of drives me crazy when I'm on Facebook and I follow astrophotography groups is the guys that take images and then of the sky and then put those on like a landscape
oh yeah.
that doesn't even apply
Yeah.
or connected to this. They're trying to.
Double images.
It's a complete fake out.
They
Yeah.
put it like behind the Statue of Liberty or something.
Yeah,
Yeah.
or one of the arches out there in
Uh-huh.
one of those national parks. This a massive thing,
Yeah.
and they're just superimposing on it. And I'm like,
Yeah.
come on, that's
Yeah. Well, yeah. When you see a deep shot of the Milky Way in New York,
yeah,
No.
yeah.
that's
It's
not going to
just
happen.
So
It's not going to happen.
fake.
So you will find posts. There's lots of people that post about like ethics and astrophotography, and they're
Yeah.
talking about like yours.
Mm-hmm.
But
But, yeah, I mean, the point is, it depends on what you're doing with it. If you're going for scientific images, you want the colors to be true. I mean, I would think you'd want the colors to be true.
Yeah.
But if you're talking about just art,
Right, it's more of
it's
an
just
art
art,
thing,
so
yeah.
just, throw whatever colors.
Can you click on that link, second from the bottom where it says sun today through the DSLR and 80 millimeter
Okay.
scope?
This was, oh, okay.
That's a purple sun.
Yeah, it's got purple.
Is that
in
a
it.
calcium sun? Is that what that is? I bet. He doesn't say, does he?
80 millimeter.
Bonder.
Vader solar
film.
film, yeah.
I think that's a
yeah,
white,
yeah.
white filter.
It's a
supposed
white
to be.
filter, yeah.
Yeah,
But yeah, it looks kind of purple on here. Might-
it does.
Well, the
Might be
reason
the
why it's because it's
projector.
from Kentucky and they always go that way.
Oh.
Maybe the projector too.
But
But yeah, I'm not looking for that, I'm looking for the yellow oranges
Oh, you
ones.
guys make it yellow orange after.
Good, exactly. Now, my filter is yellow orange, and that was Mylar film that you bought.
Yeah, I think mine is too.
And you had and I bought just a little segment from you, or you gave it to me, one of the two, but.
Oh, I think you bought your own, yeah.
Now, when people
Maybe it's me.
photograph a total solar eclipse and what's it called, the prominence, the coming out,
Outside.
I've never seen that in yellow orange. I've always just seen that in a white.
White, yeah.
I don't know if it doesn't pick that up.
That's
You
pretty
mean
good.
like the outside stuff?
Yeah,
So you have to have very narrow hydrogen alpha, I think, usually to pick that up, or some other type of filter. So really, does the colors?
The calcium doesn't show up outside, does it? The calcium is only interior.
I could see it a
That's a
little
good
bit
question.
through my solar binoculars, but, not as if I'd taken an image.
I think they're mainly picking up more closer to the infrared when you have a calcium filter, right? Maybe I should put images solar filter.
There you go.
No, now I'm getting okay.
People want to say it, they don't want to.
How come it's that color? Is that just they crossed it?
I don't know,
that way?
purple. I think the true color is kind of purplish.
I
the
think
K
that's
line.
right. I think that's right. But it doesn't show the outer edges. That's what I thought, it was only interior.
I think you have to have hydrogen alpha.
Yeah, and see, when you combine the filters with hydrogen alpha, you get the outside. The hydrogen alpha is the prominence filters.
Yeah, I don't know what this is.
Now, the solar flares, like that top one, I would usually see
There you
those in
go.
the yellow, orange
Oh, okay.
images.
Yeah, I mean, and I don't know what they did to make this. I think calcium K really is kind of purplish, more. I'm pretty
Well,
sure you
it's
can't.
393 nanometers, so yeah, that's gonna be way down.
Uh,
That's gonna be in the almost ultraviolet.
yeah, ultraviolet. So I don't know how I don't know how a color camera would actually pick that up because it's so.
Yeah,
So-
so, yeah, right.
So a lot of these I think are just done with mono cameras, and then they put whatever color they want on them.
Says
And
Well, they
calcium
just use
K-line
they just use
filter.
a calcium filter, and then with a mono,
Right.
yeah, and then they introduce their own color, yeah.
Yeah, they put it purple to make sure. Yeah, this is calcium.
Yeah,
Purple
just to
is
let you know.
almost- Yeah.
But yeah, 393 is way low. I mean, that's way below the blue, I think.
Yeah, I'm pretty sure like this is the calcium's only for photography. You can't use it for visual. I don't
You can't
think you would
use
see
it.
anything.
Yeah, I don't think you could.
Yeah.
Yeah. It's just too far down, too close to the ultraviolet.
And then the hydrogen alpha filters, like the more precision of narrow filters, the more details you could get on different parts of the sun. I don't know all the details, but it gets very expensive.
Yeah. Especially you get down to 0.4 angstroms or something. It's really tiny,
Yeah.
really tiny.
that's all. So I was kind of disappointed because I was hoping I would have, for one thing, I forgot some stuff, but I was hoping I was gonna have one of my images with I was gonna be able to take my mono camera with my RGB
We'll show you how
and
you
come
stack
up with
them
a color
together.
correction matrix
Yeah.
and have like really good color and be like, all right, I finally got this. Now I could even use this for my astrophotography, but it didn't quite get there. It's actually very hard to make a color correction matrix.
Yes, I imagine.
You
So
have to
because
transfer between different
well,
color spaces
and because, like I say, you shoot on a different night and colors change.
oh yeah, like the way that you're supposed to do it is, from what I read, I forgot to mention this, is that you use a color reference.
And how far down is it?
Sheet.
Because that starts blocking the blue.
And you use it during noon. This is what you're supposed to do.
Yeah.
You use
Yeah.
it during high noon
Right.
or whatever.
Right.
To make your, so you use one of these. You take a picture with your filters with one of these, and they have the calibration data that they come with you. So like they print these to the exact specs every time, and then they give you the calibration data, and then you take a picture of it with all your filters, and then
I remember the one you made.
oh yes, yep. But I didn't have calibration data.
No,
for
but
that.
it was just to give you an idea where
Yes.
you're going. Yeah.
And then you have to like transfer the raw data into like some other color space, and then come up with then you do
Well, you're
These squares on it.
basically doing photometry now,
Yeah.
because you're basically doing calibrating each color at the certain wavelength overhead. You know, because if you start to go down, you shift the blue out.
Yep.
So yeah, that's another reason why people don't get the same colors. It's because they shoot Orion when it's 10 degrees or 15 degrees above the horizon. It's going to look a lot redder
Yeah.
than if it was overhead.
Yep.
So and that was the thing that always got me about color images. And the reason why people don't really care about color images, well, okay, science doesn't really care about color images, except that they can specify different chemicals or different elements with various colors. But then you got to quantify that so much. It's a lot of work.
Yeah. But I don't know. I was hoping to make that color correction matrix. I might still be able to do it, but I have to learn about color spaces.
You take an image of that one.
And then it's not calibrated. It's based off this projector. I actually got a color reference, but I realized it's not good enough. When I look it up, they don't even want to give you the calibration data because they're like, our printer is not good enough. It prints it differently every time.
Yeah.
So you should only use it to compare it to match cameras, not to calibrate a camera.
Yes, right.
Yeah.
Right. No, when you start talking about trying to calibrate things, boy, your work just increased by a factor of 100. I mean, it just is amazing how much more you have to put into it in order to get a true color balance.
Yeah.
The same way with photometry. If you were to do anything but all sky photometry, I mean that gets very elaborate, and you have to take a color correct for how high up you are shooting.
Oh, really?
Oh yeah, that's part of your data that you have to do any photometric work. The altitude is important.
It's a nice image of Mars.
Oh, yeah. But I don't think the color's right. I think it's probably too yellow. But anyway, speaking of color.
That's what the 12-inch out at Farpoint.
Yeah. Well, it's going to try to show that. Yeah.
Not this year so much, but in the next couple of years, Jupiter's going to be up pretty damn high.
Yeah.
I mean, it's going to be 20 degrees up, 20-degree declination.
Mm-hmm. It'll be good. It'll be good for here, yeah. Time to get prepared.
Yeah, I'm starting to play with that a little bit, but my dark sky time is so damn limited around here.
Mm-hmm.
This place is awful to do astronomy.
Is it my understanding, the further north you get, the less dark time you have
In this
In the
time of
summer.
year.
this time of year?
Yeah, yeah. Right now, if you're out 52 degrees or, well, it's the, what do they call it, the polar zone, the tropic, not the tropic of Cancer, what's that called?
It's
Anyway,
it's sunlight all the time.
that's that
Arctic
ring
Circle?
is anything above that, and you don't never have a sunset during the summer or during this time of year.
I was trying to show. I've gotten my colors a little bit better.
Yeah,
So,
yeah.
but I still think it could be better.
Which one of those do you think is better?
This one.
I like the other one. I like the darker.
You like the red?
Well, to me, there's more dark. I don't see as much nebula, but
I don't know, there's probably as much nebula there, but it's just, yeah. But the bottom shows up better, I
Right.
think. That big nebula region shows up. The difference then between the dark and the light is more distinct. I don't know, and it's a better choice, it really is. But these guys that blow out those colors so vivid, and it's like, that's not very natural looking.
Hmm. Yeah. I guess I only have one version of this.
is that top Mars image, is that flip north and south?
It's a good question. I have no idea. I
Because
just
the,
took-
looks like
the
it.
other Mars one you have shows the
Oh,
polar
it's the other
cloud.
way.
Because I think that isn't the northern cap facing us more normally? I don't remember.
Is it ever the other way?
I
I
mostly
think
have seen it in
that
the north.
way's right.
This one?
Yeah, I think that's the North Pole, that's the South Pole.
Okay, and then
That's as I remember,
but
but
this one might be wrong.
yeah,
this
I
might
think
be-
that's
this one might
flipped
be wrong.
around. Yeah, and the reason why I say that is because you notice all the land masses are kind of narrowing to the top. And I think those land masses actually narrow to the bottom on most images.
Oh, okay.
That's the only thing I'm going by.
I have no idea.
It's a limited amount.
I could have looked it up. I think I put the time I took this. It could be looked up. August 23rd, 2020. Right, so probably would tell you it's delirium. Actually.
Well, I'm gonna go down to the voice room too here.
Sure.
That's how us old people get our exercise, going to the bathroom so much.
And let the dog out.
This is what's the. This is August. Did I get the day right? August 23rd, 2020. I don't know if delirium is totally correct or not either, but. So, I don't know. Doesn't really look like it matches up. But delirium might be wrong. So I hope I confused you more.
You know, with this hobby, you got the universe you're trying to learn about, and then you have all the technical things. It's so massive. It's you tried to be good at a few things, but
This one, I think this one could improve a lot, but this one is only hydrogen alpha, and I put fake stars in. I made the stars white. I did a starless. I took a hydrogen alpha, and I did a starless version of it by putting it in StarNet, and then I blended in the starred version so that the stars would be white and the nebula would be red.
Tycho takes stars out too.
Yeah.
It's kind of interesting to see.
so like if I have a star that's washing out the image, I can take that out.
It will automatically take out that star and leave that portion of the intensity level. It measures all the stuff that's around in that star, and then wherever that's got that big hump from adding in the asteroid image, it leaves that behind. So
So if I have a track of the asteroid,
it goes right
and
through the star.
and it's going into
Yeah.
the star
Uh-huh.
glow data, I can say get rid of it, and then I can still see the asteroid go through.
Yep.
That's
Yep.
awesome.
Yep, it's pretty amazing. It's pretty amazing. And I've been trying to use and I have trouble now even using Astrometrica because I can't get it to take the fields. It won't accept it.